Hello everyone. In this presentation, I will solve this numerical problem. This is a conceptual problem. See, in this circuit, this R1, R2 and R3, all these three resistors are in series because at the end point of R1, the starting point, the first point of R2 has started, or the ending point of R1 and the starting point of R2 has met at this point, and the ending point of R2 and the starting point of R3 has met at this point, and all these three resistors have the same value of electric current because there is no other branch connected in there. The starting point of R1 is at 12 volt and the ending point of R1 is at 4 volt, and suppose this is point A, this is point B, this is point C, and this is point D. Okay, the potential of point B is 4 volt, potential of point C is minus 4 volt, and potential of point D is minus 8 volt, and current is flowing from higher potential to lower potential. See, the point A is at 12 volt and the point D is at minus 8 volt. That means point A is at higher potential and point D is at lower potential. So we can write down there, this is higher potential and this is at lower potential. Okay, now we have to calculate R1 and R3. See, this is a conceptual problem, so I hope you will see this video properly, okay, and listen to all my or everything which I am saying. Okay, now let us see the solution. See, since there is no source voltage is given in this circuit, okay, there is no source voltage is given in this circuit, so we cannot apply VDR. Okay, we cannot apply VDR because if we want to apply VDR, we need to know the value of source voltage first. Since the value of source voltage is not given, so we cannot apply voltage difference rule to calculate this problem. Okay, but we have some other clues. See, suppose the current I is flowing from point A to D. Okay, what is the value of I, students? See, from these 2 points A and B, we know that A is at higher potential, B is at lower potential, so we know the potential difference at among this point A and B, but we do not know the value of this resistance R1, so we cannot calculate I from this branch. Now if we go at this branch BC, we see that the potential difference among B and C have been given since the potential at B is 4 volt, this is 4 volt. Okay, this is 4 volt and the potential at point C is minus 4 volt. Also the value of this resistor 8 ohm is given. So since the value of resistor 8 ohm is given, so we can calculate the amount of current I. We know that I is equal to voltage at high potential, okay, voltage or V high potential minus V low potential divided by resistance. Okay, divided by resistance. Okay, now see, we can write this is IBC. Okay, this is IBC. Now what is the value of high potential? This is 4 volt minus what is the value of low potential? This is minus 4 volt divided by resistor 8 ohm. Now IBC is I, okay, because the current that is flowing in this branch BC is also flowing from A to D, so IBC is none other than I. So 4 plus 4 divided by 8 will give you 1 ampere current. So the current flowing from point A to D is 1 ampere current. Now since we know current in these branches AB and CD, and we know the potential difference of these branches, so we can calculate R1 and R3 very easily. See, at branch R1, okay, at branch R1 we know that I is equal to V at higher potential minus V at lower potential divided by the value of the resistance R1. So we know that the value of electric current is 1 and the higher potential is 12 volt minus lower potential is at 4 volt divided by R1. So 12 minus 4 is 8. R1 times 1 is R1. So you see that R1 is 8 ohm. Okay, so R1 is 8 ohm. Now students, at branch CD, sorry, I have written down at branch R1, it should be at branch AB. No, see, at branch CD. What is at branch CD? We know that I is equal to V at the higher potential minus V at the lower potential divided by the value of the resistance at that branch. The value of the resistance is R3. Now I is equal to 1, higher potential value is minus 4, lower potential value is minus 8, okay, divided by R3. This is 8. Now what is minus 4 plus 8? This is 4, and R3 times 1 is R3. So R3 is basically 4 ohm. So you have calculated R1 and we have calculated R3. See, this was a conceptual problem. Okay, at first students get afraid. Okay, at first you may get afraid by seeing this problem, but see, there is nothing to be afraid of. Just follow your basics. Okay, then you can solve any problem. Thank you. That's for today.